In this video, I'll discuss how to sketch the graph of polynomial functions whose degree is even and having also a positive or negative leading coefficient. Let's take the first illustrative example. Say we're going to graph the polynomial function f of x equals quantity x minus 2 squared times quantity x plus 3 squared. You will notice that this function is written in factored form, meaning the right side of the equation is expressed in factored form. So we must change this to polynomial in standard form, meaning the right side contains terms whose order is in descending powers of x. By doing so, we're going to change this function to its standard form by performing the indicated operation on this side. Now, first is for each factor, we're going to expand. When we say quantity x minus 2 squared, that can be expressed as quantity x minus 2 times quantity x minus 2. While the second factor, which is quantity x plus 3 squared, can be expressed as quantity x plus 3 multiplied by itself also. And for each pair of identical factors, we can do the multiplication by using the FOIL method. Okay? So with that, f of x is now equal to, okay, using the FOIL method, x times x is x squared. X times negative 2 is negative 2x. Then negative 2 times x is negative 2x. And negative 2 times negative 2 is plus 4 or positive 4. Then we do the same thing with the second pair of identical factors. X times x is, okay, before that, let us enclose this resulting product in a pair of parentheses. Then let us apply also the FOIL method to the next pair of identical factors. So x times x is x squared. X times 3 is positive 3x. Positive 3 times x is positive 3x. Then 3 times 3 is plus 9. Then for each expression enclosed in a pair of parentheses, we identify those similar terms. Because as we all know in algebra, similar terms can be combined, which can be added or subtracted. So here, the two middle terms are similar, so we can combine them. Same thing with the second factor. There are two terms that are similar. So if we're going to simplify each of the expressions further, we have f of x is equal to, on the first factor, we have x squared minus 4x plus 4. And for the second factor, for this factor, we have x squared plus 6x, which is the sum of these two terms, plus 9. And then after that, we do the multiplication of these two trinomial factors. Okay? So with that, let us simplify this further. We have x squared times x squared is x to the fourth, followed by x squared times 6x is 6x cubed or plus 6x cubed. Then x squared times 9, that will give you plus 9x squared. Then followed by negative 4x times x squared is negative 4x cubed. Then negative 4x times 6x is negative 24x squared. Negative 4x times positive 9 is negative 36x. Then next, we have the third term, 4, to be multiplied each of these terms also. So 4 times x squared is 4x squared plus 4x squared. Then 4 times 6x is 24x, then 4 times 9 is 36 or plus 36. So how many terms do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And from these 9 terms, there are some terms that are similar. So we can combine them so that the final polynomial part of this function is this one. F of x is now equal to x to the fourth. And for the 6x cubed, we can combine this or subtract this by negative 4x cubed. So we just simply perform the indicated operations on their numerical coefficients. So 6 minus 4 is 2, then followed by x cubed. So 2x cubed. And then 9x squared can be combined with 4x squared. So, and then their sum can be subtracted or added to negative 24x squared. So the result is negative 11x squared. Then followed by those terms in terms of x. So we have negative 36x added to positive 24x. That will give you negative 12x. And then the remaining term is the constant term, so plus 36 there. Therefore, the corresponding standard form of this polynomial function is this one. F of x is equal to x to the fourth plus 2x cubed minus 11x squared minus 12x plus 36. And with this form, we can easily identify the degree of the polynomial function and also the leading coefficient, which are very important when it comes to determining the end behavior of the graph of this given function. Okay, so the first step to consider when graphing the polynomial function is determining the end behavior. And as I've said a while ago, the end behavior is based on the leading coefficient and the degree of the given polynomial function. So for the degree, we have 4, and we know that 4 is an even number. And the leading coefficient, the one besides x to the fourth, the number which is 1 or positive 1. And we know that positive 1 is positive. Indeed, it's positive, which is greater than 0. Therefore, we can say that the end behavior of the graph would be like this. The graph rises to the left and also rises to the right. The next thing we need to determine after the end behavior is the intercepts of the function. So let us take first the x-intercept, also known as zeros of the given polynomial function. Now, one thing about polynomial function written in factored form is that we can easily identify the intercepts or the x-intercepts. Taking each of the two factors, say x minus 2, taking the constant term negative 2, we just reverse the sign of the constant term and we have the x-intercept. So if we have negative 2, we have positive 2. And for x plus 3, this will become negative 3. So we have the two intercepts, and these are negative 3, which is taken from here, and this 0 or intercept occurs twice. How do we know if it occurs twice or has a multiplicity of 2? Because of the exponent 2. So we have negative 3 of multiplicity 2 or times 2, and the next, the second intercept or x-intercept is taken from negative 2. So we have 2, which is also a multiplicity of 2 or times 2. Now, and 2 from the multiplicity 2 or times 2 is an even zero multiplicity. Yeah. Okay? And your y-intercept can be easily determined from the polynomial function written in standard form. Take note of the constant term. That constant term can also be identified as your y-intercept. And again, going back to the zero multiplicity, as I have said a while ago, it times 2, wherein 2 is an even number. So we have 0 even multiplicity. Now, what does this mean when it comes to the behavior of the graph? Now, if the multiplicity from the zeros of the function is even, it means that the graph touches the x-axis at each of the coordinates at -3 and +2, and then turns around. Okay? So it means the graph will touches the x-axis at each of these two coordinates, and the graph will turn around. It will not cross the x-axis. Then what else do we need after the end behavior and the intercepts? We need also to determine the maximum number of turning points of the graph. And to determine the turning points, that depends on the degree, because the maximum turning points of the graph is always one less than the given, or always one less than the degree of the given polynomial function. So in this case, the number of turning points, or the maximum number of turning points, is 3. And with that, we are now ready to trace the graph of the given polynomial function. So we prepare the Cartesian plane. So we plot some points on the x-axis and y-axis. So let us start with those points to be plotted along the x-axis. So we refer to the x-intercept and x-intercepts, and we know that these are -3 and +2. -3 is along the x-axis, so we locate the coordinate 3, and that can be found somewhere here. Okay, because this one right here is 2, 2, 4, 6, or -2, -4, -6, up to -10, -10. Therefore, -3 can be found between -2 and -4. So we plot the point somewhere here. And then 2 is on the left side or the right side of the y-axis. So if this is 0, most probably your 2 will be plotted here. And next, for the y-intercept, which is 36, that is the coordinate 36 along the y-axis. So that is above 30, or between 40 and 30, and 36 I think is closer to 40, somewhere here. Okay, so we have, if this is 30, this is 32, 34, 36. This is the point. Wait. So we only have 3 points to be plotted. Now, let us go to the plotted point, which is on the left side. Then, according to the end behavior, the graph rises to the left and rises to the left. So, starting from this point, using a smooth curve, you draw a line going up, because according to the end behavior, the graph rises to the right, like this, and going up. I mean, rises to the left. I mean, this is the left side. Okay. So the graph rises to the left. Okay, let me correct that. Then on the right side, we start from this point and we draw a graph which is going up. And then you will notice that these two coordinates is where the graph touches, but it will not cross. Okay, so it means after tracing the graph, so if the direction is going down, after reaching this coordinate, it will turn around and goes up. Same thing with this coordinate right here. From going down, it will go up and reaches the y coordinate. And obviously, the graph that we have just drawn is in a shape of letter W. So this is your graph. Okay. Next, let us consider the second example. Suppose this time we're going to graph this polynomial function, which is again written in factored form. So f of x is equal to negative quantity x minus 1 squared times quantity x plus 4 squared. So just like in example number 1, we need to transform this function to its standard form. So I think you know already what to do. You just expand each of the square factors and use the FOIL method. And upon doing that, we could say that the corresponding polynomial function in standard form is f of x is equal to negative x to the fourth minus 6x cubed minus x squared plus 24x minus 16. Now again, if the function is written in standard form, we can easily identify its degree and its leading coefficient, which are two important things to consider when we are to determine the end behavior of the graph. So for the end behavior of the graph, the degree is 4, which is even, and the leading coefficient is -1, which is less than 0. So the end behavior is what? The graph falls to the left and falls to the right. And after the end behavior, we determine its x-intercept. So we can easily determine the intercepts by looking at the factored form. So from here, x minus 1, we can easily identify the first x-intercept, which is 1. And here, x plus 4, the other x-intercept is -4, which are both multiplicity of 2 because of the exponent 2 from the factored form of the polynomial function. Okay, -4, which is multiplicity of 2 of times 2, and 1, which is multiplicity 2 or times 2. So the multiplicity is even, okay? And, okay, even zero multiplicity. And for the y-intercept, that can be easily determined if we're going to look for the constant term on the standard form of f of x, and that is -16. Okay. Of course, for the even zero multiplicity, since it's even for 2, it means that the behavior of the graph is what? The graph touches the x-axis at each of the coordinates -4 and 1, and from each coordinate, the graph will turn around. Okay? Now, how about the y-intercept? Again, as I've said a while ago, we can easily find the y-intercept by looking at the constant term of the polynomial function written in standard form. So this is your y-intercept. Because as we know, if we are to look for the y-intercept, we always set the value of x equal to 0. And then for the number of turning points, or the maximum number of turning points, that is 1 less than the degree. If we have 4 as our degree, then the maximum number of turning points is 3. And with those things that we have determined, the end behavior, the intercepts, and the turning points, we can now sketch or trace the graph. First thing we need to do is plot those points based on the determined intercepts. So here, this is -4. Then we have +1 here, this one. And then -16, that is below the x-axis, which is somewhere here, okay? And then we trace the graph. So starting on the left side point, using a smooth curve, we draw a graph going down. Same thing with the right side, we go down with the graph. And then from each of these coordinates, the graph will just touch the x-axis and then turns around. So if the graph is increasing, upon reaching this point, it will decrease like this, and then touches or crosses the y-axis at coordinate -16. Same thing with this one, it will go down. And we have the graph which is in the shape of letter M. So this is the graph of the given polynomial function f of x equals quantity negative. F of x is Again, equal to negative quantity x minus 1 squared times quantity x plus 4 squared.